This is from assignment chapter 7, section 1. I'm going to go over some examples, actually go over some problems that we're given in here so that you can understand how to solve these. This is something that you need to understand going forward. If you don't get this down, you're going to have a very, very difficult time as we move through this chapter. The first one is we need to be able to simplify this. Tangent, oh, by the way, this is number 40 on page 362. Okay, page 63, or page 362, number 40. We're going to simplify tangent of theta cosecant of theta over secant of theta. Now there's tools that we need to use to be able to solve this. One of them is we need to know that tangent of theta equals sine of theta over cosine of theta. And if we know that, we can solve this problem. If we look at this tangent here of theta, we're going to replace that with sine of theta over cosine of theta. So let's go ahead and replace that and say sine of theta over cosine of theta. And now times the cosecant of theta. Okay, cosecant of theta actually equals 1 over sine of theta. So let's go ahead and replace cosecant of theta with 1 over sine of theta. And if we look at the bottom, we've got secant of theta, and secant of theta actually equals 1 over cosine of theta. So let's go ahead and replace that. If you notice what I'm doing here, I'm changing everything that I can in this one to sine and cosine. All right, we're going to find a few things happen. You should have noticed that right away when I put these changes in here, that sine of thetas will cancel out. And what I'm left with is 1 over cosine of theta over 1 over cosine of theta. Well, we can flip this bottom fraction if we want and bring it up, but really we're looking at the same thing on top and bottom. When we divide something by itself, it equals 1. So if we look at this, we've just reduced this problem to equal 1. All right? Just by using some tools, we are able to reduce that down. Let's take a look at another one here. Again, we're staying on page 362. Let's take a look at number 41. Let's go in sequence here. So number 41. And this is going to be cosine of theta over secant of theta minus tangent of theta. Secant of theta minus tangent of theta. Now, oftentimes, I don't know what the answer is supposed to look like. All right, I'm going to play with this a little bit to see if I can figure out what it should look like. But the truth of the matter is, until I start getting into this and I start breaking things down, I don't know. All right. Again, I'm going to put it into sine and cosine. So let's go ahead and use our tools. We got cosine on top. Let's leave that there. Secant of theta is 1 over cosine of theta minus tangent of theta is sine of theta over cosine of theta. We should notice when we look at this right here now that we have cosine of theta in the denominator on both of these. So we can combine these as cosine of theta over 1 minus sine of theta over cosine of theta. Now let's use the rule, the algebraic rule, that when we have a fraction on the bottom, we can bring that to the top by inverting it and multiplying it. So cosine of theta times, we invert this portion down here, cosine of theta over 1 minus sine of theta. All right? Well, we can multiply the cosines of theta together, and that's going to equal cosine squared of theta over 1 minus sine of theta. Now, if you look to the back of the room, I have the Pythagorean identities. And one of the Pythagorean identities that is on the very top is this one here. It's sine of theta, or sine squared of theta, plus cosine squared theta equals 1. Well, we have cosine squared theta in here. Let's subtract sine squared theta from both sides. And we find that cosine squared theta equals 1 minus sine squared theta. Let's go ahead and replace that right here for this cosine squared theta. So we end up with 1 minus sine squared theta over 1 minus sine theta. Okay, we're getting somewhere now. We're down to actually something that looks very similar. But realize that we can treat our cosines and tangents and secants and all this as x and y and whatever. Let me give you a little example and see if you can see what I'm seeing here. If I looked at x squared minus 1 and I wanted to factor that out, I can factor this to x minus 1, x plus 1. All right? Same thing if I did this way. 1 minus x squared equals 1 minus x, 1 plus x. All right? Notice that we basically have the same thing here. It's 1 minus, and we say sine squared here, but it's really like an x squared, right? So we can break this out into 1 minus sine of theta, 1 plus sine of theta, all divided by 1 minus sine of theta. At this point, my 1 minus sines of theta can cross out, and I'm left with 1 plus sine of theta. All right, this is using what we know, and you're going to start using things that you did in algebra with trigonometry to be able to solve these equations. This is where it becomes tough, because now these little things like knowing this part here, how we can break out x squared minus 1 or 1 minus x squared to be able to come out. You have to remember those. This is one of the tricks that you're going to have to be able to work with. All right? Knowing that you invert. So if you have a fraction in the bottom, if you want to bring it back up to the top up here, you have to multiply it by the inverse. Those are algebra tricks that you have to continue. And you'll find that that's going to be prevalent as you move forward here. But we'll work on them, and we'll get them down. All right, let's take a look at another one. Let's take a look at number 42. Tangent theta, cosine squared theta. This is 42. Tangent theta, cosine squared theta. You notice that I'm using theta instead of letters like A or B, or even they use beta in there. I'll just continue using theta because that's what I feel most comfortable using. All right, again, let's break this down into sine and cosine. And remember this one. Tangent equals sine over cosine. All right? So we can break this one down right away. Sine of theta over cosine of theta times cosine squared of theta. Well, right away we see that we've got a cosine squared up here. We can get rid of this cosine, and we can get rid of one of the cosines on that one, and we're going to turn out to be sine of theta cosine of theta. And there's your final answer. That one was quite easy to figure out. All right? You have to notice it and see it. So let's remember, always break it down to sine and cosine. Number 43. Number 43 is sine of theta cotangent of theta. This is 43? Yes, 43. Sine theta cotangent of theta. Let's break it down in the sine and cosine. Well, cotangent of theta really equals 1 over tangent of theta. All right? And if we look at this, we can say, well then, we know tangent of theta equals sine of theta over cosine of theta. So if we looked at cotangent of theta, really is the inverse of what the tangent is, right? Cosine of theta over sine of theta. So let's go ahead and replace that in here. Sine of theta times cosine of theta over sine of theta. My sine of thetas cancel out, and I'm left with just cosine of theta. And there's my answer. Let's take a look at number 44. Tangent of theta over cotangent of theta. Oop. That's 44. Tangent of theta over cotangent of theta. We know that really the tangent of theta, and we can change this out to sine and cosine, but I don't think it's necessary in this case because they're really both working with tangent, aren't they? This is the same as saying tangent of theta over 1 over tangent of theta. Well, here's where we have to take the fraction in the bottom, inverse it, and multiply. Tangent of theta times tangent of theta over 1, which ends up equaling tangent squared of theta. All right, let's go ahead on to number 45. Cosine, this is 45, cosine of theta, tangent of theta, and I think cosecant. Oop. Cosecant of theta. Okay. Well, let's change this off. We're going to change this all to sine and cosine. Cosine of theta, sine of theta over cosine of theta, and this is 1 over sine of theta. Cosines cross out, sines cross out, we're left with 1. Hopefully you're starting to pick up on what we're doing here. It should start clicking hopefully soon. And as you move forward, as we do these more, you're going to see this more and more. 46. 1 over sine squared of theta. 1 over sine squared of theta minus cosine squared of theta over sine squared of theta. Hopefully right away you look and see I have got sine squared of theta on the bottom for both of them. So we can combine these. We have a common denominator. And I'm left on top with 1 minus cosine squared of theta over sine squared of theta. Well, remembering our Pythagorean triple of sine squared theta plus cosine squared of theta equals 1. And if we bring our cosine to the other side of the equal sign, we end up with sine squared of theta equaling 1 minus cosine squared of theta. Well, here's our cosine squared of theta, 1 minus cosine squared of theta, and here it is right here also. So let's just replace that with sine squared of theta. Sine squared of theta over sine squared of theta, which equals 1. Okay. You see how we're using our tools. We're using the Pythagorean identities. What we've used so far is sine squared of theta plus cosine squared of theta equals 1. And we've also used that tangent equals sine over cosine. All right. We've also used our reciprocal identities where we know that sine equals 1 over cosecant theta, or cosecant theta equals 1 over sine. I would suggest, I know it's in the book, but I know that some students have gone up and taken pictures on their phones of the Pythagorean identities and the reciprocal identities so that they can remember and they can reference back to that as they need to. Let's take a look at number 47. Cosine squared over 1 plus sine. 47. Cosine squared of theta over 1 plus sine of theta. Well, we're going to go back and I look at that cosine squared. I want to break that down because I know I'm using a sine in here, okay? I can't really do anything with that 1 plus sine of theta. But I can do something with the cosine squared of theta because I know that, going back to my Pythagorean identity, sine squared of theta plus cosine squared of theta equals 1, I can subtract sine squared of theta from both sides and I come up with cosine squared of theta equaling 1 minus sine squared of theta over 1 plus sine of theta. Okay, let's go back to what I talked about before. 1 minus x squared can be broken down into 1 minus x, 1 plus x, right? We can do the same thing with the sine squared. So let's break this down. 1 minus sine of theta, 1 plus sine of theta over 1 plus sine of theta. Now 1 plus sines of theta can cross out and I'm left with 1 minus sine of theta. And that's as far as I can go. All right, let's go on to number 48. Sine squared of theta, cosine squared of theta, plus sine to the 4th of theta. Sine squared theta, not plus, not yet. Cosine squared of theta, plus sine to the 4th of theta. Oh, I did the wrong one. That's number 49. Well, I'm going to do number 49. We'll come back to number 48. I apologize. So this is 49. Well, looking at this one now, I notice that there's a sine squared of theta here, and we got a sine to the 4th, so I can take a sine squared of theta out. That's what I'm going to do. I'm going to take that right out of there, and I'm going to end up with a sine squared of theta. I'm going to take it out of both of these. And what I'm left with then is just my cosine squared of theta plus, and if I take a sine squared out of sine to the fourth, I'm left with a sine squared of theta. Well, what's sine squared of theta plus cosine squared of theta? It's 1. So this ends up just being sine squared of theta. Let's go back to number 48 now. Kind of did this a little out of order, but that's okay. 48. Cosine of theta over 1 plus cotangent squared theta. So cosecant, right? Yeah, cosecant theta over 1 plus cotangent squared of theta. Well, if you look on our Pythagorean identity triples, it's also in your book too. These Pythagorean identities are also in your book. You're going to see one of the identities is cotangent squared theta plus 1 equals cosecant squared of theta. Well, if you notice this here, it's the same as this right here. So let's switch that out. Cosecant of theta divided by cosecant squared of theta, which equals 1 over cosecant of theta. If we look at our reciprocal identities poster, you'll see that 1 over cosecant of theta actually equals sine of theta. And there's your answer. Let's go on and do number 50. 1 minus sine of theta. This is 50. 1 plus sine of theta. Does this look somewhat familiar? Does this look like when we factored out 1 minus x squared into 1 minus x, 1 plus x? It should. So we know if that's true, we can do this with the sines also. This turns out to be 1 minus sine squared of theta. What's 1 minus sine squared of theta? That's right. We can go back to our Pythagorean identity. It's cosine squared of theta. And there's our answer. The last two, 51 and 52. If you can solve those showing me how to solve them, I will give you, I believe it was 10 points. Extra credit points on the next test for Chapter 7. So I'm going to leave those up to you, 51 and 52. Solve one of them. Again, look at them if you have to in the form of, remember, put everything cosine or sine and cosine, or look at them, you know, when you have cosine to the fourth, do it as x to the fourth. Cosine squared, do it as x squared, and see if you can figure that out using those terms.